Okay, let us look at the zero index. The zero index. Most times or sometimes when we are dealing with indices, let's say when we are multiplying or subtracting, we sometimes find us having a number which has a power of zero. Like for example, in this case, when working out a power 2 divided by a power 2, you end up having, according to the division law, this will be a power 2 minus 2, and the answer is a to the power of 0. So according to the zero index, any number which is not 0 that has a power of 0 equals to 1. If any number has a power of 0 and that number is not 0, then it is always equivalent to 1. So meaning that in this case, if we got a power 0, this is equivalent to 1. So even if, no matter how big the number is, even if it is 1, even if it is a million to the power of 0, it is always equivalent to 1. Even if it is, no matter how big it is, as long as it has a power of 0, it is always equivalent to 1. Even if you're multiplying two numbers or 3 or any numbers in a bracket, but they still have a power of 0, still the answer will be equivalent to 1 because they are still raised to a power of 0, and you get any number to the power of 0 and that number is not 0, the answer is 1. Okay, so let's look at some of the tricks that we shall use when solving positive indices. So whenever we are solving positive indices, especially when we are opening the brackets in this case. So if you have two numbers which are inside the bracket and then they are raised to an index, or what we call a power. So each of these numbers inside the bracket shares the power or takes its own portion of the power. So meaning that the answer here will be a squared, b squared. So this power of 2 is taken by a and it's also taken up by b. Each of those numbers inside the bracket takes a share of the power. So even if the two numbers are being divided, or that is, even if it is in a division, this will be similar to having a squared divided by b squared. So you can see that a takes the power and b takes the power. So in general, if you have a number ab to the power n, this is similar to having a power n and then b power n. And if also you have a out of b to the power n, this is similar to having a power n out of b to the power n. Okay, so let's look at some of the examples which involve that law that we've looked at. The first one is 2a power 3. So if we have 2a to the power, everything rises to the power of 3. So this is similar to, so the 2 will share the power and the a will also share the power of 3. So this will be 2 power 3, a to the power of 3. So of course we know that 2 power 3 is the same as 2 power 3. It means you multiply 2 3 times. We looked at that when we are introducing indices, and which is 8. So meaning that the answer here is 8a power 3. Okay, if you look at part B here, which is 3y, the 4 is shared by the 3 and the y, so we shall end up having, for this, we shall end up having the answer as 3 to the power 4, then y squared, so y squared will also take on the power 4. So finally, we shall end up with 3 power 4 multiplied by y squared is the same as y 2 times 4, because this time it is the bracket which we have to remove. So you can go ahead and calculate 3 power 4, which will end up giving you 81, then y to the power of 8. as the answer. So 3 power 4, you multiply 3 4 times. Then if you look at maybe the last part, which is this, where we are solving 2a power 5 being multiplied with 3a to the power of 4. So in this case, what you do is that you can collect some of the like terms, that is, take the a's together and also collect the 2 and the 3 together, since for them they are whole numbers, and then you also bring the a's closer to each other, or what we call collecting like terms for a and for the whole numbers. Then we go ahead and apply the indices, especially on the laws of indices on a. So 2 times 3 is 6. So if we apply the laws of indices on a, since we are multiplying, we add the powers, so it will be 5 plus 4. And finally, we shall end up having 6 times a to the power of 9. And the answer will be 6a. The answer will be 6a to the power of 9. So basically, that is how we deal with indices. So the same thing, even when you're solving numbers like this, you still apply the same trick that we've looked at. There is no bigger difference. Like in this case, collect the 24 and the 5, you bring them together. So in solving this, we shall end up having 24 multiplied by, so we bring the 24 and the 5 together, and then collect the a's, a power 6 times a power 3, and then on the denominator we have 8a power 7. So you can even go ahead and multiply 24 with 5. So when you multiply 24 with 5, you get 120. Get 120, then a power 6 times a power 3. When you apply laws of indices, you'll have to add 6 and the 3, and you end up having a power 9. Everything being divided by 8, 8a power 7. 8a power 7. So if you reach here, you can even reduce if you want. You could have even reduced on the first step. There is still no problem. So whether you reduce from here or you reduce on the next step, there is no problem. So if you reduce 21, if you reduce 120 and 8, the easiest factor to use is 120 and 8. I think the easiest factor to use is 8 itself, or you can just divide 120 by 8. So if you divide 120 by 8, you get something like 15. 120 by 8, you get 15. And then you also solve a power 9 with a out of 7. So meaning that we shall solve 120 out of 8 separately, and this will give us 15. And then also you deal with the a's alone, that is a power 9 divided by a to the power of 7. So of course this, when you apply laws of indices here, it will be a power 9 minus 7, and the answer is a to the power of 2. So meaning that the answer here is 15a to the power of 2 as our final answer. So still you can see that we are applying the laws of indices when working out such situation. So if you want, you can also first reduce, especially when you want to avoid using the calculator or getting very bigger values. You can start by reducing the 24 and the 8, and you reduce the numbers further for you to get a simpler value for you to deal with. Okay, so please, you can also try out these questions here such that you get used and you apply these principles more and more. The more you apply them, the more questions you do, the more you get used to using these principles.